everyone, it's Nupur again. So this week I wanted to talk about a concept that's probably a lot simpler than the concepts I've been discussing in the last few videos. So, given the side lengths of a triangle, what do you do if you want to find out the area? If you're me, what you try and do is drop an altitude from this top vertex and then split the base into these things and then solve for E so that this way you can just multiply C by E and then divide it by 2 using the Pythagorean theorem to solve for all of these variables. This is a very fine and dandy strategy, but if you're an impatient type of person, this might get too slow for you. Thus, we present Heron's formula. This is Heron's formula. The area of a triangle is equal to the square root of the semiperimeter minus a side A, the semiperimeter minus a side B, and the semiperimeter minus a side C, where the semiperimeter is, of course, A plus B plus C all over 2. Now this sounds awfully convenient, right? Let's try it on a triangle. There. Now the semiperimeter is going to be 3 plus 4 plus 5 all divided by 2 is equal to 6. So now we just need to take 6 times 6 minus 3 times 6 minus 4 times 6 minus 5. This is going to, by the formula, it's going to give the square root of 36, which is equal to 6. And of course, we can just multiply these and divide them by 2 because this is a right triangle to verify a result. Now, just to make sure everyone understands the concept, we can try this on a triangle where we can't check our answer so easily. For example, what if we change this 3, 4, and 5 with 5, 6, and 7. Now what? Now the semiperimeter is going to be equal to 9. So we need to find the square root of 9 times 3 times 4 times 2. This is going to be equal to the square root of 216, which is equal to 6 times the square root of 6. Note that I did in fact verify this using a Pythagorean dash. It's not really that hard to do by dropping an altitude and solving, but it is a lot slower than just using Heron's formula. However, Heron's formula becomes pretty useless if we make the little correction like so. Because then who wants to do all that multiplying involving square roots? For me, it's a little too much effort, so I'd rather just stick with the Pythagorean dash. In fact, seeing as I couldn't remember Heron's formula for the longest time, I've become pretty used to using the Pythagorean theorem to find the area of a triangle from its side lengths anyways. But who knows, maybe you really hate that, in which case, be glad that Heron of Alexandria came up with this helpful formula. Thank you, and I'll see you next week.